Good morning, everyone. Thanks for waiting in the wait room. Hopefully, you can all see the cover slide for today's webinar presentation for Iowa Bridge Inspection Manual Training with a focus on LPA agencies and personnel. I see more people are joining on every minute, but want to honor the time. You guys are on time this morning. And just a reminder that this training is being recorded for future use by Iowa DOT. So I don't want that to discourage you from asking questions using the Q&A button. We may not answer the questions as you ask them, but we plan to leave a few minutes at the end of this hour to answer those questions for you and have some discussion. But you'll be limited to muting, so use chat to ask or contribute. And I'll go ahead and turn it over to Mike Todson.
Hello, everyone. This is Mike Todson with the Bridge and Structures Bureau of the Iowa DOT. Thank you for joining us this morning. This presentation is focused mainly on the changes on the Bridge Inspection Manual due to changes in federal regulations and coding requirements. Class is planned for 50 minutes and presentations, 50 minutes presentation and 10 minutes of Q&A at the end. And it is geared towards local agency bridge inspections, covering, all right. Okay, I think we're good then. You can flip the slide.
Okay, that's it.
All right, a little outline of what we're going to be doing today, some history of the project, introductions of our presenters, the overarching changes, Chapter 1, which is the general regulations and administration of the bridge inspection policies. Chapters 2 and 3 we are not covering. Those cover state-owned bridge inspections. And Chapter 4 will be condition evaluation of bridges. Chapter 5 is QA/QC. And then we'll go into what's next. Quick note, this does not specifically cover Local Systems Bureau IM 7.020 for bridge inspection, but these two things are closely tied together and you will hear it referenced. You can think of the Local Systems IM as policy and this inspection manual as guidance. And a couple definitions going forward. This is based on the Federal Highway Administration, FHWA requirements. These are spelled out in the National Bridge Inspection Standards, the NBIS, and relate to the National Bridge Inventory, which is the data we submit to the feds. That was previously specified in the recording and coding guide for the structural inventory and appraisal of the nation's bridges, last published in 1995, commonly referred to as the coding guide, and the changes now to the specifications for the National Bridge Inventory, the SNBI, or sometimes called SNBI. And so you'll hear those terms referred to very frequently during the day. Okay.
Okay. My name's Paul McGinnis. I'll do a better introduction in a few slides, but I work for Michael Baker, and we were contracted by Iowa DOT to update the manual, as Mike just discussed. We decided and we agreed it would be best done in phases, with the first phase starting in 2023. We started with a survey of you folks and users, both at the administrative level down to junior inspector level. We've done that with other states and find it's useful to understand the demographics of the group that this applies to. And we do that when we teach the NHI courses. As you know, if you've been in them, we ask you questions about your background so we understand your background going forward. But we also ask questions about your training, and these slides are some graphic examples of showing that we found out that most of you have more than 10 years of inspection experience. However, half also felt the need for more training. So that's an example of why one reason we're doing this webinar today. And the results were in our phase 1 report, and it helped guided the needed updates in addition to the SNBI that we knew needed updating. We reviewed multiple inspection reports as well that were written by you and state inspectors, and obviously the existing manual cover to cover and flagged areas to be updated per the NBIS. The project history continuing. Phase 2 was then actually updating the manual per NBIS and SNBI. 508 compliant might be a new term to you. That's basically making it accessible to individuals with disabilities, and that is a federal requirement for public manuals. Note that in this presentation, we're making SNBI items blue font to draw attention to that new coding, and the new manual does not include the erratas for SNBI. Some of you are familiar with it, know that there's already one or two erratas out that they're tweaking and adjusting. So those will probably be incorporated once they're approved. At least, federally, the manual updates may lag behind. The state manual update might lag a little on that. It is compatible with the Sims fields now, and also it's on the Sims homepage. We made it easier to update, so please provide feedback to your managers as you use this manual. If you see an error, a mistake, or something that's ambiguous. And we are now wrapping up phase 3, which was 3 parts, 2 parts of training, one to the DOT, one to the LPAs, which we're doing now and highlighted in green. And then what we're wrapping up now is a chapter 6 to clarify how to use Sims and how to navigate Sims. Obviously, there's information on Sims platform as well, but this will just help, and that's coming soon. It'll be published or put out with the manual, added to the manual. So as promised, we were going to introduce ourselves. So I'll start with myself since I have the mic. Like I said, my name is Paul McGinnis, and I'm the project manager for Michael Baker. I was also one of the principal authors, and you can see my years experience there. I also lead Michael Baker's bridge and structure inspection practice. We do inspection for about 30 bridge owners throughout the country, and I'm also involved in NHI FHW teaching of bridge and tunnel inspection courses. So, Mike, why don't you introduce yourself? Mike O.
Okay, thanks, Paul. My name is Mike Orlowski. I've been with Michael Baker now for 25 years, and I've been in the inspection industry since 1997. I'm our Denver office bridge inspection lead. I helped Paul update manuals for multiple agencies, I think 5 or 6 now, and I'm currently the QA specialist for Montana DOT. Thanks. Mike?
Hello, I'm Mike Toddson, the Bridge Maintenance and Inspection Engineer for the Iowa Department of Transportation. I've been with the Bridge and Structures Bureau for over 30 years now, starting in the design side, and for the last 20 years plus have been involved on the inspection side of things, mainly focusing on state bridges, but now overseeing the whole state system. Kevin?
Kevin?
Yes, Kevin Verheyen, the Sims manager for Iowa DOT. Been doing that for the last 4 years, and previously had other experience in a lot of other different asset management softwares.
Okay, I'm going to talk about some of the overarching changes to the manual. This whole webinar, being an hour, is really a summary of the changes and emphasizing changes. Since if something didn't change, you're already familiar, so why train you in that or teach it? So basically, there are changes to personnel requirements with the new coding. That's you can see on the right. That's the NBIS first page of the new standards. And you can see the different parts that always existed, but there's changes within them. And that includes some of the requirements to become an NSTM team leader or other positions, in this program. We also deleted some antiquated language from the 2015 manual. At that time, we were discussing structurally deficient, functionally obsolete bridges. We've eliminated that terminology. The feds have, so have we. And it's no longer used. So we pulled those out and focused more on poor, fair, and good to replace that. Our main theme was don't fix it if it isn't broken, or in this case, don't change it if it's not required by the new regulations or state laws. So if something in the manual worked, you'll see it hasn't been changed. We kept the structure of it. We even kept separate chapters for state versus LPA because of the differences in those requirements. We did like the definitions and abbreviations, but we moved those to the appendices to get it out of the body, more of a reference as you'd expect to see in an appendice. And then we also, wherever there was passive language, such as the team leader, or this should be done on Form XYZ, now it would say the team leader must do this on Form XYZ. So more clear, less fuzzy language, less optional, and more what you need to do versus what you don't need to do. Chapter one is still chapter one. It has pretty much the same organization, but each section had some updates. So we'll walk through these one at a time over the coming slides. The purpose, now every chapter has a section up front, but this has the purpose for the full manual, but each chapter has the purpose of that manual in a paragraph form to kind of quickly let the users know, especially new users, what's in this chapter, not just the table of contents, which is helpful. And there are hyperlinks within this to help you jump back and forth. But it was the purpose to organize, document, and combine. We did add 4 goals or outcomes associated with this purpose that you can read in the bottom half of the slide. And those are associated with the purpose and all while adapting the new regulations. Section 1.1, we still have the bridge diagrams, the isometric diagrams. We like those. We kept those there. We just added this additional one, which is a 2-girder floor beam stringer system. So, but these are good because they promote consistency of labeling different components across the state, as well as new users or new people new to bridges who may not know bridge terminology. So kind of like your version of the berm. NBIS history. The previous manual had a nice page on history pre-2015. Here's some examples and photos of what has transpired in the last 10 years. So bridges still have issues. They haven't gone away, but we condensed the old history and we're introduced some new examples of problems and not just what failed, but why it failed, obviously, to know why and learn from that. So some of these were caught before they failed, other ones after the fact. But obviously, the purpose of the inspection is to not have what we have at the top of the photo, but maybe, catch what we have at the bottom right, but before it gets to that stage of cracking, obviously. So that's one reason we do NSTM inspections so thoroughly and hands-on. Note that most of these did involve NSTMs, and we also added a summary up front of the new NBIS regulations and also the SNBI. Okay, Mike's going to talk about the organization in Iowa.
Yeah, a little bit about our organization at the DOT. One of the requirements of the the NBIS is that the organizational requirements, and one of those things is the written policies, which this manual helps to fulfill. Our organization, I serve as the program manager for the state of Iowa and oversee not only state bridges, but county and local or city bridges as well. Then helping me is Eric Saradov on the local side is the main contact. He is the local agency coordinator, and you're probably familiar with working with him. Kevin, of course, is helping with the SIMS access. If you do have questions concerning SIMS, I would encourage you to use the email address on the SIMS website, as we have a couple people monitoring that, so we can assure that you'll get a quick response in case someone is on vacation or out for the day. And then not shown on this group, we have Dave Bear, the snooper operators and the inspectors, and you may be familiar with Dave. If you've rented a snooper from the state in the past, he coordinates that. And also shown in here is Sean Sursland. She oversees our rating unit, and you may have some contact with her concerning load rating of bridges, and she is working on the updates for the um, new load rating software switch. Okay.
Okay, thanks, Mike. Section 1.2.3, this section outlines the qualifications for inspection staff. We're going to talk about a few personnel. First and foremost, program manager. To be a program manager, you're going to need either a PE or 10 years of bridge inspection experience. In addition to that, you're going to have taken and passed an FHWA approved comprehensive bridge inspection training course, followed up by refresher training every 5 years. To be a team leader, there are multiple avenues. Years of experience are going to vary based on your education. For example, if you have a PE, you can be a team leader with only 6 months of bridge inspection experience. If you don't have a college degree, you're going to need 5 years of college experience. Similar to program manager, all team leaders do require FHWA approved bridge inspection training course. Take it and pass the exam, followed up by refresher training every 5 years. For team leaders to lead NSTM inspections, they're going to have to take and pass an FHWA approved NSTM training course. That's the old fracture critical. Similarly, if team leader's going to lead a dive inspection, they're going to have taken and passed an FHWA approved underwater bridge inspection training course. Load rating engineers, they're going to need active Iowa PEs, and all certs should be uploaded to SIMS and uploaded and updated as required. Next. Okay, so this chapter talks about the different inspection types and intervals. We're not going to hit on all of them. As far as intervals are concerned, I will mention those. Some inspection types don't have intervals based on their nature. So let's get into it. Initial inspection, that's the first inspection performed for a bridge when it's put into the inventory. Or initial inspections are also done if a structure has been significantly modified via rehabilitation. Routine inspections, these are the most common type. These are the bread and butter inspections for the typical types of bridges throughout the state. The interval for these is not to exceed 24 months. They can be reduced for poor conditions. Underwater inspections are for the inspection of underwater bridge components. They've got to be in at least 2 feet of water for it to be considered an underwater inspection. And once you hit 6 feet, boom, you need a diver. The interval for these inspections is typically 60 months. Again, if conditions are poor, we can reduce that. If conditions below the water line are good, we can actually stretch that to 72 months. NSTM inspections, these are hands-on inspections of NSTM members. Think trusses, think two-girder systems. The intervals for these inspections is no more than 24 months and similar to above. When conditions are poor, those intervals can be reduced. Damage inspections, think bridge hits. These are inspections of things that were damaged by unforeseen events, errant vehicles, overheight vehicles striking girders as they pass underneath, etc. Special inspections are targeted inspections of known defects that you want to get your eyes on more frequently than 24 months. These inspections can be utilized in place of a reduced interval routine inspection, which is nice because now you're just looking at those bad conditions instead of the entire structure. So I kind of think of these as a defect monitoring inspection. And speaking of monitoring, actually, scour monitoring inspections. These are inspections of bridges over water after a triggering rain or flood event, as described in the bridge's scour plan of action. So basically, once that rain event or flood comes, you're going to go out to the structure when waters go down a little bit to check for undermining, scour, and structure stability. Next slide. So this chapter addresses safety. We are bridge inspectors. It's our job to inspect bridges. But above and beyond that, it's our job to come home safe every single day. So if you're out there in the field and you encounter something unsafe, hit the pause button, assess the situation, adjust as necessary to make sure that you can do your job safely, not only for yourself, but also for your team and the traveling public. Some of the safety risks out there are obviously going to be your traffic, weather, deep and fast channel flow, and equipment failure or misuse. Speaking of equipment operators have to have the proper MEWP LPA certifications, mobile elevated work platforms. Know that if you're certified for a bucket truck, that doesn't mean that you can run a snooper. And when you're in buckets, please stay tied off. When you're working in water or above it, use your life preservers. And if a bridge requires confined space protocols, please follow those. Keep your safety certs up to date and uploaded in SIMS. Next. So this slide, this chapter talks about statewide policies. First one's pretty important. Be sure to submit all coding data for the MBIS bridges in SNIBI within 90 days of the inspection end date. Know that SNIBI now applies to public bridges with to private bridges with public roads on each end. That's a change with the new MBIS rules. I think that was 2022. This chapter has some really good guidance for temporary bridges and bridges with temporary supports. Not shown on the slide, this chapter also outlines policies for bridge orientation and labeling, critical finding policies, and policies for non-regulated structures. Those structures include head bridges, culverts under 20 feet, and privately owned structures that are not open to the public. Thanks.
Okay, thanks, Mike. As promised, we're skipping over chapters 2 and 3 and jumping to 4. These are the sections within the manual within chapter 4, which is the condition evaluation of bridges, focus on LPA. And we are focusing pretty much on try to focus more on the gray SNIBI coding items versus the black and white or translated one-to-one coding items. But there's not really any changes to the bridge elements or MBE since the previous manual, because that hasn't changed, but typically don't code elements for the LPA bridges anyway, so that's not impactful here. So we'll walk through quickly, and there'll be one or more slides for each of these bullets. Okay, as I said before, each chapter starts with an introduction, and basically the added intro describes what's in the chapter. It also serves as a reminder that you are inspecting some of the older and poor condition bridges that are in the state, owned by LPAs. And as I'm sure you've already noticed, SNIBI will require much more time coding, and there's more inventory data prior to inspection that needs to be coded, as well as during inspection. As part of your inspection planning, you'll need to adjust your field forms and sketches to obtain this information, additional information, and verify information that's transferred over. And note, in this case, this field for B.EI items or IE items stand for bridge and inspection event. So most of these are dates, so it's when these events occurred, what date. Also notice that most dates, some are repeat and some are new ones. In terms of section 4.2.1, these are just a good reminder that when you hear the word appraisal items still are not impacted by the condition of the components. So there's no change there, just as, compared to standards as if they were in good condition. One of the items that we're evaluating is overtopping likelihood. There's a table now included in the manual that has a number coding 0 to 6, where the higher the number, the more likely or more often will be anticipated overtopping. And for now, it's using your judgment, but there'll be more to come on that. When it comes to railings, the good news is you no longer need to code items 36 A, B, C, and D, but now they have an equivalent for items 36 A and B, and now they have a much more involved table to the right that talks about test levels and crash methods such as MASH and NCHRP reports. But for Iowa inspectors, Iowa's created this new guardrail guide on the resources pages of SIMS to help you determine these crash levels and code the appropriate coding in SNIBI per the table on the right, which is in SNIBI, and also I believe is copied into your manual. Not everything in SNIBI is copied into the manual, otherwise that would, be too redundant. So that's some of those items, appraisal items. Then we have the condition rating codes. So they start with B.C, so bridge condition from 1 to 15. I highlighted, we outlined those in red that are new. So we always, we're doing deck, super, sub, or if it was a culvert condition rating. So that's very similar, 0 to 9. But now they've felt that it's important to identify the condition of the bridge railing, the transition, bearings and joints as well, give them their own separate condition ratings. And then the tables in SNIBI will help you with that. Um, so some of these are also coded G, F, or P for good, fair, or poor. So don't just drop in a number, but it would probably reject, an input that's not allowed by the format required. So you'll get the hang of that as you do these. BC12 is a calculated value. So the other input is important to be accurate. So that will be accurate. And then the channel and scour ratings are coded under 9 through 11. And we'll go into these in more detail in the next few slides. So inspection procedures. I figure with this slide, instead of just summarizing, reviewing the bullets, which you can do, just an example bridge to the right. And the question you might ask or should ask if you're going to inspect it is, do I need a U-bib for this, or can I do it from the ground or boat? And if you went into the manual, it would tell you that if there's 5 or more spans over water, then you need to use a U-bib, but not every cycle, but every 6 years. So another question might be, well, if I'm doing a ground inspection and boat inspection and I see what might be a significant problem, say on the superstructure or deck, then what do I do about that? Well, you can finish your report, but then you can ask for a UBIV at the next cycle, or you can schedule a special inspection. Mike talked about those. You could do, special inspection if it's isolated locations, and maybe start doing a 12-month inspection of those areas with the UBIV, and maybe not the whole bridge. So common sense engineering judgment for that. The other thing is you can see now SNIBI and NBIS wants to know if the bridge has fatigue prone details, but the manual will clarify that we're talking about E and E prime only and not the lower fatigue prone details that exist, such as D and C. Pin and hangers. Um, some people think of those as, since within itself, an assembly may only have 2 hangers, and that's not, redundant. However, if a pin and hanger is on a 5 girder system, then it is on a redundant system. So it's easy to remember, if it's not part of an NSTM member or attached to an NSTM member, then it's not NSTM. So, but pin and hangers are obviously special features, and we don't see them that often. And then last thing I just want to mention is with NSTMs, we all know what those are now, but what is in the coding is if you have NSTMs in the superstructure and the substructure, and they each get their own, they have different condition codings based on their, actual condition, then you would rate the lower of those 2 numbers. You would code that. Then we have channel protection ratings. Here we have 2 distinct codings, 9 and 10. 9, think of that's what the existing is like, and 10 is are there any man-made countermeasures, and if so, what's the condition of them, and are they doing their job? So I underlined existing and man-made for each of these just to emphasize that. And so obviously existing could be alignment issues, scour, undermining, etc. But then when you get into protection, you'll see and be using terminology such as bank protection, revetment, armoring, dikes, spurs, things like that are man-made devices, riprap even, to try to control scour and erosion. So notice the difference between those. And just a question, rhetorical question is, which of these 2 items would be impacted by the condition of vegetation on stream banks or the presence of sandbars? So if you think of those two situations, both of those are naturally occurring. It's rare to have a man-made sandbar. So being natural, they would affect the channel condition rating BC09, and it wouldn't impact the BC10 rating because they're not man-made issues. Just a little bit more on this. So another photograph of a bridge on the right. And up until now, item 113 from the Federal Coding Guide was used to rate both existing and potential scour vulnerability. It was kind of a combination of both, and that created some issues or concerns. So FHWA, I think, smartly separated actual observed scour from potential for scour. the second being more of a calculated thing that we'll talk about on the next slide. But just what you'd observe if you're an inspector taking this picture, hopefully, you would document the scour you could see that's under along the profile of the bridge. But you'd also want to ask yourself, well, how deep is that mud line? How deep does it go? So you do some drop lines. It's a little difficult to get a boat in here, so this might be difficult access, but not just the depth to the mud line, but how soft is the mud or how hard is the material below there? And do we have plans and what's the length of those piles so that if there is 10-foot scour hole there at the near column, that's might be a deep scour hole, but if that's a 60-foot long pile, then it's probably minor, not moderate or major.
Exactly.
So here is what I was talking about, the scour vulnerability, which is an appraisal item 03. So it's AP. When you see AP, that stands for appraisal. And so this is based on the bridge's resistance to scour, which requires plans, maybe even boring logs, hydraulic engineer. As inspectors, you wouldn't rate this, but if you see a lot of observed scour, then it's more important to get a hydraulic analysis to get a proper 0 to 9 coating on this item. So if you look to the photo, I'm sorry, the diagram on the right, now you have more information about this bridge and the situation. You can see that the scours is isolated to the fascia pile in this case, so that impacts your observed scour rating or condition rating of it. And as I said, you'd provide this information to the hydraulic engineers that would then do the APO3 condition rating or calculations for that. Also, scour POAs may be of use when coding these items as well. And then they would code it as the scale of 0. It either hasn't been done. So with item 113, it was sometimes the default was like rated a 6 if it hasn't been done. But in this case, we're indicating there hasn't been a calculated scour appraisal, or it has been calculated and determined to be stable all the way up to scour critical. So we still use those terminologies, scour critical. Then when it comes to channel components, this is a field that has been in SIMS and will continue to be in SIMS. However, these are not SNBI items. So just be aware that what you enter into SIMS, some are SNBI required, other ones are agency required that they'll continue to run with and carry, at least, for the near term. However, some of them are associated or related with each other. So the condition ratings provided for the SNBI items that we just talked about, the channel condition and protection, 9 and 10, will be impacted by these items here, the scour, erosion, drift, vegetation. So we can see these 6 and 7s satisfactory to good condition ratings. So if on this bridge, you would expect BC 09 and 10 to be fair to good and not poor or severe ratings. So they should jive with each other. And you would enter those on the channel form within SIMS. Okay, I'm going to turn it back to Mike Todson.
Okay, thank you. The process for assessing scour vulnerability that we have been using has not been changed as a result of the updates to the NBIS or SNBI significantly, and is based on the information available in the local systems IM. For those familiar with it, the main part of that is working through attachments A and B of the IM to do an initial scour assessment and continuing on to any further evaluation if deemed necessary. One thing that has changed is the coding for the scour assessment. The SNBI has different coding than the old coding guide. So you have to make, it's not a one-to-one comparison. So you have to make sure you're using the right values there. And we will be updating the IM to reflect the SNBI coding in the future. Don't have a date for that yet, but that will be happening. Plan of actions, if required for the scour assessment, still need to be uploaded in the SIMS, and the SNBI has requirement for recording the plan of action status, and that is a 0, no, or yes. Zero's not required, no is it hasn't been completed, or yes, it's in place. And the scour analysis is now an ABCD type coding instead of 1, 2, 3, 4. Kind of helps with recognizing the difference in the new coding. For unknown foundations, that assessment will still remain the same based on the information available in the IM. And next slide. All right, for recording this in Sims, old item 61 is now BC 11, again with the new coding requirements for that based on the observed conditions. And the descriptions in the new guide are different from the old one, so you need to pay attention to that. Scour Critical, again, that has been updated to the ABCD type format as we were just discussing. The Scour Critical assessment is the same as before. And while we required the plan of actions to be coded, it is now a part of the coding guide, so we'll be following their coding methodology. And the recording for the unknown foundation analysis will remain the same. And next slide. All right, bridge posting. This has changed a little bit. We now have PS01 and PS02 to describe the signage on the bridge. PS01 is now a 2-component item with first identifying the bridge as permanent, temporary, or supported, and then the second letter being the posting status, similar to the old item 41. Then PS02 is the date, and the FHWA is looking for that to be the dates the signs are installed on the bridge. On the load rating evaluation section, this has changed somewhat. There's now multiple places to enter multiple truck types. It has the classic AASHTO or FHWA rating vehicles are pre-coded in there, such as the 3, 3S2, 3-3. And then there are additional places for states specific vehicles, EV vehicles, and whatever may come up in the future. All ratings now are recorded as a rating factor, so you've kind of lost the option of recording tons or rating factors. Everything is to be recorded as a rating factor. Then if it requires posting, they require the posting type, which is the type of sign. In this example, it shows T. T would be for a silhouette type posting sign that has the multiple truck silhouettes with a posting limit for each one. And if it was just a gross weight restriction, that would be coded G. And there's several codes in there for different types of posting signs, depending on local or state requirements. Then the posting value is the value that is on the sign for that limit. So here shown with the silhouette posting, there is a different posting limit for each type of vehicle. And every time there is a change in the load rating or posting, these items need to be updated. All right, and then we have in Sims, there is a area for the readability or visibility of the posting sign, and that will remain the same as good, fair, poor. Okay. All right, and here I think we discussed the bridge railing a little bit earlier. And now the transition is part of the coding where you use the same value for the condition of the railing is based on the crash test evaluation. And the condition is section is the observed condition. And then I guess I'm a little out of order here. The alignments are now coded as good, fair, poor based on speed reduction while crossing the bridge. And this is their criteria: none, noticeably, and substantially. And this kind of goes to a common theme in the SNBI of leaving some room for interpretation. And I think in the future, we will be providing some more guidance on some of these items to help with consistency. But we don't have that yet. And I know pretty much every state is struggling with some of those interpretations. Okay.
Okay, thanks, Mike.
Yeah.
Oops, I think I jumped 2 slides. Oh no, is that right? Okay, Sims documentation. Yeah, that's Kevin. Yep.
Yep.
Yes, so we're not going to go too much into the updates that have been changed specifically since the 2015 manual. That'd be quite a long process. One change that we did is that the naming convention from the two manuals, as you can see in the red boxes, we're calling those now menus and not modules. As mentioned before, the feds have removed sufficiency rating and functionally obsolete, and they have replaced that with the bridge condition classification. That's going to look at your four main condition ratings, and those will be funneled into B.C.13, which is the lowest condition rating, and that will establish B.C.112, the condition classification, the good, fair, poor that has been replaced of the sufficiency rating. One other calculated field that we have done is in the past we had been doing the deck area. That's now a required field. So that is in there. And then we have added the inspection due date for all the different inspection types. That is looking at B.IO3's completion date, and then adding in your frequency or interval on B.IEO5. So we're always looking for opportunities to do calculated fields where it makes sense to reduce the amount of calculations for everyone. Next.
Okay, thanks, Kevin. I'm going to cover photos and sketches next. And don't forget to ask questions as we go along, and we're leaving a few minutes at the end. If we don't see many questions, we won't leave a lot of time at the end of this. But really no changes to how you attach photos, sketches, or plan documents that are required. But as we all know, improper posting of either weight or under clearance or obstructed signs, like Mike said earlier, the visibility gets rated good, fair, or poor. Well, you should have a photo of that, even if it's good visibility, to verify that the posting level is correct for that bridge or that approach. We've inspected some bridges where one direction is posted 40, the other direction is posted 28, and it was the same bridge, same roadway. So some things like that can happen. As always, we want the poorest conditions photographed, but it's not necessary to get photo for every repetitive defect if it's very, very common or repetitive. The previous flow chart that was used for this was more of a tree style diagram, and it's not really a flow chart. It's just a diagram to make it easier to read, and more importantly, to promote consistency on how you describe components that are defective. For instance, if someone said there's a spall on the near abutment or wing wall, that makes sense. But if you said there's a spall on abutment 1 return wall, it's like, well, in Iowa, we don't call them abutment 1 and 2, and we don't use return wall. We call them wing walls. So different states use synonyms or, for the same component. So we want to be consistent this way. The next one, 442, is basically Scott had already told me before he left that you guys were good at filling out this load rating evaluation form and the instructions help that are provided on this form. I know the font is pretty small, but it's on the right, and also down below is the part of the form and the instructions on the right. In this case, if you look closely, you'll see they're all ends, so it's pretty obvious that this bridge will not need to be load rated, but it's important to distinguish between when some become yeses, does it mean that a bridge needs to be reload rated? And the answer to that question is not necessarily. It depends on which question is yes. And some may just trigger the need for a professional engineer or a load rater to determine if it should have a reload rating. Critical findings report. And that is, you'll still need to contact the responsible local official immediately when you suspect a critical finding to verify that. And then also if it's on an NHS, the FHWA within 24 hours. And you'd need to complete part one of the CF report within 48 hours, but don't wait, till you complete that report to report it. And we listed condition ratings that would require a CF reporting here on this slide. And that's also, I think, per the SNBI. So that automatically triggers a CF if you have, for instance, a deck condition rating of a 2 or an NSTM rating for any NSTM that's a 3 that drives the, NSTM item BC14 down to a 3. So I think that would make sense since we're into serious critical category there with those numbers. But that doesn't mean that's the only thing that could trigger a critical finding. We all know there's a lot of different situations that can create a structural or safety related deficiency that shouldn't wait to be remedied. A loose deck haunch over a roadway, for instance, won't drag any of these ratings down, but you don't want a precarious spall over live traffic. With channel cross sections, you will be performing, or at least, looking at channel cross sections. And this slide also shows what would trigger need for more detailed measuring or inspection. So if you're measuring the upstream cross section and the depth of the mud lines per the plans, or you can see exposed footings, then that triggers getting down there and measuring along the length of that substructure unit to verify how much of it is exposed or even potentially undermined to condition code BC11. If in this case, you wouldn't have to do a bathymetric survey, but that could be triggered as well. And then if the stream migration is significant, especially since the last inspection, having an aerial photo like this from a drone is a luxury, but even without this, that's more important to have a map of what the stream alignment looks just upstream and downstream. So these different things would need to be, noted in your inspection report. And then NSTMs, we've touched on these in a couple different ways, but in this section, not much has changed except now we call these NSTMs and not FCMs. Probably the tricky area, and always has been and still is determining which floor beams are considered NSTMs and which ones are not. Sometimes it's obvious, but the manual currently has bullets that indicate whether you should consider it based on the spacing of the floor beams, how it's connected to the truss or the main girders, or even stringer connections to the floor beam. But this is being reworked by FHWA. They're going to provide clarification to all states to make it more formulaic on how to determine and agree, nationwide, not just within each state, what is an NSTM floor beam and what isn't. And there's a lot of studies on redundancy too that are probably going to be involved in that decision. So 461 is maintenance recommendations. And you check the box for the recommended option types. They're listed in the table. And what we've done with this table, we've subdivided the table now into deck, super, sub. Before it was just a long list, so we try to make it easier to go down. If you're thinking about substructure recommendations, you can jump right down to the bar that says substructure and then just look for those substructure codes and corrective or preventative options so that you code properly and quicker and more easily. Okay, I'm going to turn it over, I think, to Mike now.
Yeah, thanks, Paul. Chapter 5 discusses quality control and quality assurance for the LPA bridges. A lot of people don't quite understand the difference between quality control and quality assurance. It can be a little fuzzy. You know, it took me a little time to really wrap my head around it when I was a young engineer. So the basic definitions are as follows. Quality control is defined as procedures intended to maintain the quality of bridge inspection reports and load ratings at or above a specified level. Quality assurance is the act of making sure quality control practices are adequate and implemented by measuring the quality of an inspection and load rating program. So what's the difference? Well, quality control really is the processes that we implement to produce good work, and quality assurance is the measure of that quality, and that'll tell you if those QC processes are working. Quality is measured at QA reviews. Those are done by field engineer specialists, as we're going to discuss later. Next slide.
There we go.
Okay, thanks. So there were very few changes to these sections in the bridge inspection manual. So I just want to talk a little bit about QC and who performs it. Well, quality control starts with the inspectors. Inspectors should review the previous inspection report before they actually go out in the field. It'll prevent surprises. And the bottom line is that preparedness really does lead to quality. When you're out there before you leave the bridge site, inspectors should be reviewing all the data that they collected for completeness, make sure they got all the measurements, all the photos. When you do that, you're going to leave the site knowing that you have everything you need to generate a complete and accurate bridge inspection report. And finally, inspectors should be reviewing their own work after they've done all the inputs into a SIMS prior to submission. If the inspector doesn't have time, or if he prefers having somebody else on your team review that, is always a good idea. It's always good to have fresh eyes on something that you wrote yourself. I know that SIMS will also help with quality control. It has some built-in error checks. SIMS will throw up error flags that are going to prevent report submission until certain issues are resolved. SIMS also will remind inspectors of late reports. It's also going to let program managers, it's going to make them aware of unapproved reports that are waiting for their action. And finally, there are independent QC checks. These are done by the LPA program manager or an independent team leader. That's somebody who was not on site. Those people will perform a quality control of the submitted report. They're going to be looking for accuracy, completeness, and compliance with current standards. And other reports may be sent back to the team leader for corrections based on what they find. Okay, so that's who performs QC. We're going to be talking about QA on the next slide, but before we go, if you keep your eyes on the right side of that slide, items checks. Those 12 items are going to be related to the first type of QA review that we're going to discuss on the next slide. Go ahead, Paul. Okay, so first up, the first type of QA review is a bridge records review. These are done for a sample of a random sample of the LPA bridges. Basically, they're going to review the bridge record to ensure that the 12 items on that previous slide are indeed in the bridge file. Things like plans, SINA forms, and load rating calculations. The second type of QA review is the one that we're probably most familiar with, most people. These are team leader QA reviews. These are performed, like I said, by a field engineer specialist. These occur at least once every 4 years for every team leader. The reviewer is going to check to make sure that the team leader has all the proper certs and training and that everything's up to date. And then that person will also perform QA reviews of 10 bridges that the inspector inspected in the last 10 years. So the bridges that reviewed, they're going to be the typical bridges that the inspector inspected the last year or so. They're not going to pick the one-off bridges. They're going to look at the meat and potatoes of what they were doing. We're also going to look at bridges with lower condition ratings. If you look at a bridge that's in really good condition, there's really not too much to look at. Do know that the team leader will be present for 2 of those field reviews, so you're going to be out there rubbing elbows with the guy who's actually reviewing your work. Know that the team leader is scored. They're going to use the QA review sheet for that. Any negative or recurring findings are going to have to be resolved. So if a team leader's out there and he's constantly missing X, Y, or Z, we're going to come up with a way to correct that. And know that findings from these team leader QA reviews are reported to the Iowa DOT. Finally, a quick blurb about load rating QAs. Just know that these are conducted by BSB using SIMS. Thank you.
Yes, so as we stated earlier, Chapter 6 isn't quite yet finished. That will be added as we go forward. The one key thing to know about this is that Chapter 6 will be more of a how to use Sims, not how to input into Sims. So it's not going to tell you how to do an inspection, just more of making sure that you know how to create and move through the program. So just keep that in mind, that it's more as a how-to, not a inspection tutorial. That's what the rest of the manual's for.
Okay, thanks, Kevin. As you can see, it's 5 of. We have time for questions. Reminder to use the Q&A if you have a question about anything we've covered this morning, or maybe something we didn't cover that you'd like to get that question out there. And Kevin and Mike are available to you, as well as I believe it's Eric, right? Or am I getting the wrong name? Yeah, that you guys work for also. While we're waiting to see if any questions come up, I just wanted to say appreciate you spending the hour with us this Friday morning. Roughly 100 attendees attended this training either yesterday, today combined. But if you have a colleague or a consultant who couldn't make either of these trainings, Mike could speak to this, but I will likely post one of these recordings on a website for your access or your inspectors, or even 6 months from now when you want a refresher on what we covered today.
Yes, yeah, this will be available on our website in the near future. And I would like to thank everyone for attending today. And as always, if you have any questions, comments, concerns, please let us know. We'll be more than happy to talk to you and help you figure out your situation. Thanks everyone for joining us today.
Yep, thanks, everybody. I appreciate it.
Thank you.
Okay, I'll go ahead and close the meeting then. Not seeing any questions for anyone. So thanks again. Have a good weekend. Bye.